Section 13.5 is the cosine function. I can graph and write cosine functions, and I can solve trigonometric equations. Big ideas here. As the terminal side of an angle rotates about the origin, beginning at 0, its cosine value on the unit circle decreases from 1 to -1, and then increases back to 1, because our cosine is our x. Okay, so in a circle, we start at 1, we go to -1, and then come back. Looks more like a lemon there, pretend it's a circle. A non-translated cosine function can be completely described in terms of its amplitude and period. The cosine function, y equals cosine of theta, matches theta with the x-coordinate of the point on the unit circle, where the terminal side of an angle theta intersects the unit circle, and that's shown in the graph on the bottom of page 861. So on 861 there, they have the graph of the cosine function. Interpreting a graph, in example 1, says what are the domain, period, range, and amplitude of the cosine function. So when we look at that graph on the bottom of page 861, its domain is going to be all real numbers. Remember, domain is x, and here that's our theta. We can plug in any number we want to there and get a value. The period, or the amount of time it takes before it starts to repeat, is 2 pi. It starts at 1, max, 0, minimum, 0, 1. And at 2 pi, we start over again. The range is our y values, how high it goes. So its lowest value is -1. And its highest value is 1. So it's always in between -1 and 0. Lowest value, -1. Highest value, minimum, maximum, everything in between. You also could have done an all real numbers there, in between, instead of a y. And the amplitude, its distance away from the theta axis or the x-axis, is 1, both above and below. So its amplitude is 1. All real numbers. 2 pi. We have the range in between -1 and 1, and the amplitude is 1, again, because that's how far away it goes from its midline, and its midline is at 0. There's no up and down shifts, so it's how far away it is from its center line. Examine the cycle of cosine function from the interval 0 to 2 pi. Where in the cycle does the maximum value occur? And where do the minimum values occur? Where do the zeros occur? So if we look, okay, the maximum starts, I'm going to just draw a real quick sketch here. It looks something kind of like this. 2 pi, -1, and 1. Maximum values are at 0 and 2 pi. The minimum is halfway through at pi. And the zeros are pi over 2 and 3 pi over 2. Again, we take our 2 pi, split it into 4 pieces, so 2 pi divided by 4, pi over 2. We have pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So the zeros, again, are x-intercepts, and those happen at pi over 2 and 3 pi over 2. For the sine function, remember our sine function looks like this. The domain, again, is all real numbers. The period is 2 pi. We talked about that in the notes for yesterday. Range, okay, our highest value is at 1 and our lowest value is at -1. So again, it's -1 less than or equal to y, or you could do all real numbers there, less than or equal to 1. And the amplitude is 1. It's distance away from that midline of 0. The maxes, here we just have 1. and it occurs at pi over 2. And the minimum occurs at 3 pi over 2. Zeros are intercepts. So that's all the times where it's 0. It occurs at 0, pi, and 2 pi. 0, pi, and 2 pi. There are x-intercepts. Note on page 862 is our properties of the cosine function. Y equals a times cosine of b theta. Absolute value of a is our amplitude. Again, if it's negative, that just tells us the reflection. The amplitude itself is the absolute value. B is the number of cycles between 0 and 2 pi. And 2 pi over b is the period of the function. Guys, that's all the exact same as it was for the sine function. Same ideas as a sine. The only difference here is to graph a cosine function, a 5-point pattern is max, 0, min, 0, max. Okay? And that's because this is our x value. So we start at 1, then go to 0, then go to -1, then to 0, and back to 1 in a circle, on the unit circle. Example 2 here is sketching a cosine function. Sketch one cycle of y equals 1.5 cosine of 2 theta. So same idea as when we did the sines. Our amplitude, or our a value, is the 1.5. That's how far up and how far down we are from that midline. Here, since we don't have any vertical translations, it's just y equals 0. The 2 is our b value. And our b value is 2 pi divided by b, gives us the period of the function. So our period of the function, or the amount of time it takes for, or amount of distance covered for one cycle, is pi. So when we go to graph this here, y-axis and our theta axis here, go ahead and label this theta since we have a theta in our equation. Okay, for cosine, we start at our maximum. So I'm going to go ahead and mark that at 1.5 because that's my amplitude. Same away, so since I went 3 above, 3 below, again, that doesn't really matter. Just happens to be the habit that I've gotten into. And then we mark out our theta axis as well. And again, these need to be split up equally. So I have 3 spaces there, 3 spaces there, 3 spaces there, 3 spaces there. Total of 12 spaces. My period is pi, which means I'm going to mark my last one as pi. Take pi and divide by 4 because I have 1, 2, 3, 4 sections. And so each one of my marks is going to be pi over 4. Then I'm going to have 2 pi over 4. I'm going to have 3 pi over 4. I'm going to have 4 pi over 4. 2 pi over 4 simplifies to pi over 2. 4 pi over 4 simplifies to just pi. Guys, if it confuses you having those pi in there, think about them as fractions with like a label of pi. We just put the pi in at the end. So 2/4 is a half, so pi over 2. And 3 pi over 4. Okay, again, cosine, we start at our maximum, then 0, then our minimum, and then 0, and then our maximum. Those are the points we use for cosine. So I'm going to connect those here. And again, this should be like a curve, not a V. Mine looks kind of like a V. Should be more of a curve. And there's a picture of that in the book. Now, sketch one cycle of y equals 2 cosine of theta divided by 3. So our 2 is our amplitude. Okay, that's our stretch up and down. How far away from our midline? this right here, guys, we can rewrite as 1/3 theta, which means b equals 1/3. Theta over 3 is the same as 1/3 times theta. So our b is 1/3. We use that to find our period. So our period is going to be 2 pi over b. So we take 2 divided by 1/3 or multiply by the reciprocal, and we get 6 pi equals the period of our function. So drawing my axis here. Six pi is my period, so that's what I label my fourth one as. Now I take that, and since I split it into 4 pieces, I'm going to divide it by 4. I'm going to simplify and get 3 over 2. And again, I put that pi in last if you want. We can think about them as fractions with pi multiplied at the end. It's a constant. It's kind of like a label in that it's 3/2 pi. 3 pi over 2. Okay, that's my first one. My second one is 2 times. My third one is 3 times. My fourth one is 4 times my 3 pi over 2. And again, 3 pi over 2 is what I got when I took my 6 pi, my period. Oops. Shifted that. Let me fix it. Sorry, when I took my period and divided it into 4 sections, I got 3 pi over 2. So here's 1, 3 pi over 2, my second section, my third section, my fourth section. I can do a little bit of simplifying here. 2 divided by 2 is 1, so I go 3 pi over 2, 3 pi, 9 pi over 2, 6 pi, which is like 1.5 pi, 3 pi, 4.5 pi, 6 pi. So now I'm going to label those on my graph. We have 3 pi. Sorry, I have 3 pi over 2 is my first one. Then I have 3 pi. Then I have 9 pi over 2, and then I have 6 pi. A quick check, guys. Our last one and our middle one. Okay, the middle one is always half of our period. So 6 pi there, we should have 3 pi here, and we do. Next, I'm going to label my amplitude by 2. That's, again, how far away from that midline here, and since we don't have any vertical or horizontal translations, there's nothing I need to change there. I just go 2 up, 2 down. Since we have cosine, we go max, 0, min, 0, max, every time. So max, 0, minimum, 0, max. And again, try and make this a little bit curvy because we're going based off of a circle. Okay. And that's all I'm going to put on this first video. I'll finish on the second one.